Welcome everyone to the Onshape Research Symposium panel discussion, Understanding Collaborative Design with Onshape Analytics. My name is Peter Zink. I'm a former Boston University Mechanical Engineering faculty member. I taught CAD there, which is how I got to know PTC, among other things. And now I'm helping to lead the PTC Education team. I'm honored and delighted to be able to speak today with our distinguished panel. We're joined by Ian Gardner from AvidBots, Alison Olachewski from the University of Toronto, and Stanko Skic from the University of Zagreb. Thank you all for joining us. So as many of you know, the unique cloud-native architecture of Onshape enables real-time, seamless, collaborative design in a way no other CAD platform does. And in case any of you aren't familiar with Onshape Analytics, as Ilya mentioned, Onshape stores every change made to an Onshape document while a user is working. And this allows us as users to analyze not just the designs, but the designer's behavior, to look at what they did and to see how their actions change as they use Onshape. And so this in turn gives us an opportunity to develop practical insights to help improve collaboration and efficiency in real product development. I'll share a slide here, one moment. Great. And so I'm really excited to learn here from our panel today how people can best engage in collaborative design with the help of Onshape. And just a reminder to the audience to please put any questions in the chat. So to begin, I'd like to ask each of the panels to briefly introduce themselves and give us their perspective on the following question while they're speaking. Just briefly, in the increasingly connected and agile world of product development that we're experiencing, especially hardware product development, which is really just nascent, what are the biggest opportunities that you see for engineers and designers in that space? And how do you think modern tools like Onshape can help? We'll start with Alison and then Stanko and Ian. So go ahead, Alison.
Great. Thanks, Peter. Hi, everyone. It's great to speak and really interesting to hear from Jordan and Ilya this morning. I learn something new about Onshape every time I come to a symposium like this. It's really great. So I'm a professor at the University of Toronto in mechanical and industrial engineering. And my field of research is called design theory and methods. And so as Ilya mentioned earlier, there does exist a whole field of engineers who study not only the tools, but the tools and their interaction with the designers to think about process and methods. And so that's what we focus on at my research group, ReadyLab. This slide is pretty busy, actually. And I would say that that's because my lab is pretty busy. There's a picture of my great students in the middle. And because of many of the features that Ilya mentioned in his talk, we've just seen really an acceleration and explosion of research in the direction of human-centric CAD, I would call it, in my group. So we have a ton of projects we're working on. We're inspired by software development and software engineering, working with some collaborators here in electrical and computer engineering at the University of Toronto, Shu-Rei Zhou, and other education researchers and CAD researchers doing a broad variety of work. To answer Peter's question, I am really excited about the future of CAD because I think, as Jordan mentioned, CAD as a tool, we sort of thought it had reached a certain level of maturity. But I think we thought that partly pragmatically because we didn't have access to the type of data that would help us answer even more questions and get even better. And so I think that we can learn more about the way humans design with CAD and especially how humans collaborate with CAD. I think that could unlock productivity and creativity. So we need to focus there. And I think also understanding how humans design and humans collaborate can help us understand what we could use new automated tools, machine learning, artificial intelligence, what we can do with those techniques and CAD and humans to make design better. So yeah, thanks, Peter, and excited to share more perspectives from my lab and the research that we do.
Thanks, Allison. Stanko?
Yeah, thank you once again for this great event and for invitation. Also, thank you for nice introduction. By the way, just to check, can you hear me well?
We can.
Okay, that's good. So my name is Stanko Škec. I'm assistant professor at that Faculty of Mechanical Engineering and Naval Architecture at the University of Zagreb, and actually my lab overlaps in terms of let's say research studies and education with, for example, what Allison does in Red Lab. So I work as a part of chair for engineering design and product development and CAD lab. And our research and educational focus is obviously on various topics related to different aspects of engineering design, from design methodologies, design management, usage of design methods and support tools, but also within more specific domains like such as design for additive manufacturing. Of course, within that context, we explore a variety of CAD, human/user, depending on how you want to call it, or CAD behavior research issues. And we also, for that, we use Onshape environment. I must admit that it actually helps us a lot, especially for analyzing collaborative aspects of engineering design. And within that context, I'll just try to mention some of the topics that we try to tackle: identification of CAD activity patterns, comparison of desktop CAD versus virtual reality practices in terms of workflow, and how actually these tools support collaboration, for example, within design review activities. Also, how to explore and how to analyze individual and team CAD working practices. How I believe that about some of these studies we'll discuss today. So I believe maybe we can leave more for later.
Great, thanks, Stanko. Ian, would you like to introduce yourself, please?
Yeah, thanks, Peter. And like my fellow collaborators, I'm very pleased to be invited and discuss the future of Onshape and answer your question specifically about the opportunities that it makes available. So I'm coming from the industry perspective, where the rubber hits the road of all of these tools and using them from a design perspective. So I work for a company called AvidBots, and we make an industrial floor cleaner. And I've worked with Allison to make our team's data available for her research, and she gives us insights into possible ways that we could increase efficiencies across our team. So our main product is both the floor cleaner itself, and also something that's new in our industry is making data about the way the robots behave, where they've cleaned over time, putting all of that data and making it available to our customers in a cloud-based format. So there's a lot of interesting parallels in the cleaning industry and making data available to our customers, just like the CAD industry is now providing data to all of its users. So our company and Onshape, I see a lot of parallels between them. And to go back to your original question, Peter, what opportunities are opening because of Onshape? We talk a lot about data, but I think what data really enables us to have is a perspective over time, something that we've never had before in CAD. We could say versions of things, but the way that Onshape makes data available to us, we have a perspective over time, and that makes it easier for us to make good decisions on the way that we apply our efforts, the way our team is organized, and the way we can design our products faster. So yeah, I'm very pleased to be here, and yeah, I'm looking forward to our conversation.
Great, thanks, Ian. Stanko, I see you have your hand up. Feel free to.
Yeah, I realized I missed the question, so I haven't responded to that.
Okay.
So can I share my viewpoint on that?
Please.
So I think now that especially after COVID, and I think that we all experienced, let's say, quite an increase in virtual and remote work, and also I think many companies introduced and kept hybrid work now as a new organizational practice and routine. And I think that this transition actually caused many changes, and I think many consequences we'll be able to identify and recognize them. We'll still need some time. There's still a lot of work to do, but I think that actually this could help us to better understand and monitor the way projects are conducted and implemented. And very important thing regarding this Onshape analytics is that it's in a non-intrusive way, which I think it's very, very beneficial for practitioners and also researchers. And I think that those visual CAD tools actually could help us a lot in that sense. And Onshape is, I think, one very successful example, and to actually understand how they collaborate and work on everyday level, which I think very often it's very hard to grasp that data. Also, I think that maybe this could potentially help us to understand characterize some project footprints for different types of projects. So for example, for innovative projects or maybe incremental projects, and then we can use them as a baseline. So I think there are many opportunities how Onshape Analytics could help us.
Great. Thanks to all three of you. That was great to have you here, and great to hear that. You know, I hear you talking a lot about we can gain insights about user behavior from the data we can get out of the Onshape Analytics audit trail and the other aspects of it. And it's fascinating to think we can even get to maybe be able to increase creativity and productivity and efficiency, and especially the perspective that's pretty fascinating. And you know, perhaps I'd like to start with Allison on the next question and ask if you could just talk about your research a little, and speaking of these behavioral insights, you know, how your research uncovers insights about user behavior, and when or how collaborative design really happens.
Sure, absolutely. So we do have a lot of research going on, but I'll sort of summarize in two different pillars of that work. So one is only thanks to wonderful partners like Ian and AvidBots, which is the opportunity to analyze true natural design data. And so Onshape has helped us with Ian and AvidBots' full permission to export all of their audit trail data, so all of the sort of modeling clicks that their designers do in order for us to analyze that. And it's, from a researcher's perspective, it's a huge amount of data. In fact, I should have the number off the top of my head. I don't, but I think my student Phil is here. So Phil, if you can chat the sort of scale of the most recent AvidBots data set, that would be awesome. What this lets us do is to really get a sense of what real designers, how they go about performing their CAD work. So for example, on Ian's team, there are about 16 designers working in CAD. And what we were able to do with the first data set that Ian's group shared with us was be inspired a little bit by something, by personality tests. So maybe you folks have tried the Myers-Briggs personality tests. It's a big simplification, but it says, you know, people sort of have general styles that they fall into, and we can learn about the way we should be collaborating on teams by thinking about the balance on our teams and the way some people tend to act together. We thought, is there sort of an equivalent in terms of the way engineers CAD? So from the audit trail data, we were able to see exactly what each designer was contributing, what types of features they were using, what types of actions they were taking. We could then cluster this, and we sort of came up with some CAD archetypes. So it's really only at a preliminary stage now, but we found some really interesting results there. So for example, we came back to Ian's team and we showed the results that we found, and we said, we noticed these two people, for example, have a pretty similar CAD personality. And Ian told us that actually those two people share a pretty similar role. They're at similar level of expertise. We told Ian, this person is sort of a standout in terms of the breadth of features that they use and the volume of features that they use. And Ian said, that's actually me. I'm the sort of chief user. I was the one who was exploring Onshape in the first place. I'm really pushing it. I'm really trying to become the expert. So it's really cool that we could figure this stuff out just from the clicks alone. So that's sort of an example of this natural observational data. On the other hand, we do some more controlled laboratory experiments where instead of letting Ian's team just do their normal design work, we give our participants a really specific design task so that we can compare oranges to oranges and apples to apples. So so far, sorry, let me just say that Onshape is really enabling for that type of research, because in the past, it's been super hard to recruit CAD designers in Toronto to come into our lab and do our experiment. Onshape, browser-based, lets us recruit people around the world. With Zoom, we can record their screen and talk to them. Then with Onshape, we get all of their clicks, we get their model. It's really a comprehensive data set. And we've been able to recruit widely. So far, we've been looking at individual designers, but we're about to roll out those experiments to consider teams as well. And in the past, when we've looked at pairs of designers collaborating, we've found trends that show that when designers work together, they end up with higher quality CAD models. That might be because they're able to sort of error check each other, keep track of the requirements while they're working. Sort of 4 eyes are better than 2 eyes. And we've also noticed that 2 designers working together tend to have a more satisfying experience. As humans, we like working with each other. We tend to be social. We sometimes even make jokes with each other. So of course, there's frustrations that come with collaborating on a CAD file together, but there's also a lot of upside in terms of engagement and satisfaction. So that's just a little bit about our work, but there's so much more.
Thanks, Allison. Really cool to hear that you sort of have a natural laboratory as well as a more controlled one to work in, and how Onshape, because of the browser-based nature of it, enables that in a way that we can't do with a desktop CAD system. Ian, I'm curious to know how and what maybe can you talk about how you're able to leverage Allison's results and insights that she gains from your data? Are you able to then look back at your team and change or improve how your team works?
When I think about what research really means, I think about you're holding attention and gaining insight into the things that you're looking at. I think these researchers, they have a particular skill, an amazing ability to look deeply into the nature of things and then draw insights out of that. So I think what I've noticed with Onshape and looking at this data, it kind of parallels what I think has happened. Pioneers before us have gone to build fantastic championship teams. If I think about baseball or basketball, all of those sports, they look deeply into data and gain insight on how to build a championship team. And they have every stat that you could possibly imagine. Years ago, they started collecting these without knowing the power that it could have to make good business decisions to build teams. I think this very same thing can happen within professional teams who are using CAD, understanding what we do, the types of actions that we do can help to guide our team to become more efficient in the way that we produce outcomes and get to design decisions faster, make better decisions. So yeah, in collaboration with Allison, I think she's helped us to gain some insights into our team members and our team structure, searching for great talent out there and bringing on the right mix of players to spark ideas amongst our team is something we're always searching for. But yeah, like building any championship team over time requires patience and cultivation. The more insight we have into our players, the better team we can build.
Great. That's really fascinating to think about it. It's a good analogy for it. Yeah, and it's important to understand, of course, it takes time, and that is an evolution, I imagine. Allison also mentioned that you're developing or finding some CAD archetypes through the results of your work. And I think Stanko, you've mentioned that you think about digital signatures that you can recognize as well from Onshape. Stanko, could you talk about that a little bit? What you mean by those and how they manifest and what we might gain from them?
Yes. If you would analyze different research studies, you would see that people previously analyzed different types of digital footprints. So, for example, they analyzed emails, they analyzed, for example, inputs from some different other visual tools. So, for example, collaborative collaboration within Miro, for example, and different types of tools were being analyzed beforehand. And CAD was not that much, especially due to multi-CAD environment, due to various issues which are related to single CAD user environment. And I think this actually opened many possibilities in terms of, for example, analyzing. So when we are talking about CAD archetypes, we should be aware that there are different, let's say, facets of CAD behavior. So, for example, we can analyze activities, actions that they do. So whether we could analyze to what extent this design work is iterative. So, for example, to what extent they combine creating activities, editing, reversing, deleting, how they change throughout design process, also how they're related to individual parts and assemblies. And I believe that some of these results could be quite surprising because, I mean, if they're surprising, they could lead to early warning indicators and showcase that maybe there are some potential issues. Of course, this could then be beneficial both for, I don't know, for example, team managers, but also engineers to navigate the process slightly different and give some guidelines. For example, focus more on bottom-up approach for this type of project, or maybe top-down cataloging approach for the other, or maybe focus on creating activities in this initial part. If they start too early with editing activities, that potentially could maybe lead to maybe they had less maybe creativity activities very early in the process. So there are different types of CAD activities that could be linked to their behavior. Of course, we need to be aware that CAD data can offer us quite a lot, especially, but we need to take into account the context. So the context of the project, to what extent CAD is used, and to what extent CAD is crucial for certain type of project. And whether it's from the early, maybe conceptual phase or embodiment or quite late embodiment. So these are all things that we need to take into account. And of course, to get overview over the whole engineering work, we need to couple of course, other data sources. So what people do, they use protocol analysis. They analyze different verbal exchanges in order to get to have more insights on the context. And this could actually help us also to understand when they work synchronously or asynchronously, and also to analyze their workload distribution, because maybe sometimes their distribution within CAD activities could be, for example, number of activities is lower, but maybe they could provide more added value. So some of these things we need to be careful when we are analyzing. But as I said, I think that this could help us to maybe spot some early warnings, so to identify some early warnings, also to give us guidelines on how to tailor the process on fly in real time, identify high performing teams, which is, I think, Ian mentioned champions, but I think also high performing teams, maybe we need to be aware that team composition influences quite a lot. So it's completely different to compare, for example, team out of 3 or 4 members to a team of 16 members, which has completely different interaction and communication and different working routines. So yeah, I think there are many possibilities, and it's about, I think, coupling. So once we establish the let's say baseline analytics and try to understand some basic let's say behavior, then potentially it's about coupling different aspects to try to see and to provide more guidelines to practitioners.
Yeah, thanks, Stanko. It's fascinating to think both in the professional space that we could look at very high performing teams, analyze their behavior, and maybe then understand some best practices which we could share across an organization. And similarly in the education space, we could look at what maybe are successful behaviors for learning and leverage them in the same way. You know, Ian mentioned a team, analogy, and I couldn't help but think about, we work closely with First Robotics, and I think about, we have First Robotics teams, which are a great example of students collaborating to create a design in Onshape. I wonder if any of you could talk about how you might expect to see features of a team collaboration like that, and how they might look differently from a professional design team. Could you tell the difference just from the data, or or what else might we need to know? Would anyone like to address that? Yeah, Allison, please.
Yeah. Well, I think this is probably a research question that Stanko and I would both be really interested in pursuing more. And I'd love to hear Ian's perspective on it too. But I do have some insight from a project that we worked on. My research student, Felix, who is now actually an intern at PTC, which is great, and Matt from the Symposium, and Chris Rogers at Tufts, we worked together on something called the multi-user CAD collaborative learning framework. And there we built this sort of analytic system that would take the Onshape analytics and spit out sort of a distribution of actions by team members who have worked on an Onshape project together. So we did an activity with a mix of CAD beginners and CAD and experts, and asked them to design a playground. We generated a bunch of data, and then we ran this through the MuCAD CLF as sort of a demonstration. And so far we're interested in getting more data to get more trends. I think this is a really interesting question of what differs between a low performing team and a high performing team, or a team of experts and a team of novices. But something that we do notice, and is a really interesting passion that I'd like to focus on in my research, is the fact that we often see on a team where there's a little bit of a skill distribution, that one person, likely the person with the highest CAD skill level, tends to dominate the design. So we actually recreated this result with our collaborator Igor Werner from Technion, who's also on this call, some of the data from his class. And maybe you've seen me present this before. I sort of provocatively call this dominant designer the CAD guy, because it tends to be a male student. And this student tends to be sort of like a gatekeeper on the design. In fact, we noticed that they do some actions more than some gatekeeping actions more than the other members of the team. And for me as an educator, this is really important because on the one hand, Onshape enables this collaborative design environment that desktop-based CAD never did before. So in the past, all the student projects that I ever worked on where we used CAD, one person would be the CAD guy, truly there, have the CAD file on their machine and do all the CAD work, which also means sort of hogging all the CAD experience and skill building. Now Onshape enables this more broad sharing of that skill building, but we might still see the same tendency for one person with more skills to sort of dominate the rest. And I'm curious, like in Ian's situation, maybe that's good. Maybe you want your CAD pro really leading and pushing, but certainly in an educational setting with a bunch of beginners, you don't want the rich getting richer and the poor sort of being left behind. If we think skill rich or skill poor. So again, that's something that we've sort of described this problem thanks to Onshape data. And next up, we want to start to try figuring out maybe some interventions. I like Stanko's idea of sort of an early warning system that says, hey, we've looked at the initial data from your project. We see this imbalance. What can we do about it? So my student Liz is working on this. And if you have any ideas for this, please let us know.
Thanks, Allison.
That's
Ian?
really interesting. Sorry, I'm just going to
Please.
jump in because that's a fascinating question about the difference between a professional team and student teams when it comes to FIRST Robotics. One of the other hats that I wear is I teach a CAD at a local college. I have a few CAD classes, and we have Onshape there. And there's 500 users that have registered and used Onshape there. And when I look at the way they've used it, their data, what always fascinates me is that you have users who have no idea that a data management system is happening there in the background, and they're completely free to roam and create. And Onshape accommodates for making a big mess. It allows students to creatively discover the tools as they're learning. And I think this would be a characteristic of early FIRST robotics teams, is that they are using the tools and it's easy to make a big mess. And one of the characteristics of a professional team is they would start with kind of a mess of ideas at the beginning, but they would be able to organize that and sort of move it forward faster towards a consolidated design. And I love that Onshape allows for all of that creative work to happen. Someone mentioned the word unobtrusively. It's very freeing to know that your data is not going to crash, your models aren't going to crash, and you can sort of explore different ideas and bring them back together. And yeah, I'd love to explore more what you were saying, Allison, about a CAD dominated design, because I think in previous, like in the development of CAD over time, usually a company would focus on one model, or one team would focus on one model. And so I can naturally see how that would be dominated by one person. In my team, because it's easy to branch and explore multiple ideas, I do see younger designers in the team feeling more free to explore something. And soon it goes over some of the initial stuff that maybe the dominating leader would have designed, and they just eclipse it, but it happens very seamlessly. So maybe in some ways, the whole team, the CAD design is becoming more democratic and spread across the team. I can see that within our own team, but I'd never thought about it that way before.
Thanks, Ian. Really interesting. Yeah, fascinating. Stanko, do you have anything to add to this? Especially around collaboration, I think it's really wild to think that there's now a whole different way teams might work on things.
I mean, I agree with what was said before. As one of the early warning indicators for example, educational domain could be, for example, if someone is not contributing enough. So it immediately, you can immediately identify an individual which actually underperforms, or on the other hand, you can immediately spot someone who outperforms. So I think that on the other hand, I would expect that, for example, in professional settings, maybe we could expect a more balanced workload within team. But this depends, as Alison mentioned, on the role they had on the project. Also, it depends on the number of projects that professionals work at the same time in parallel. Also, whether we are talking about metrics, project, or functional organization. So there are different influencing factors which actually could cause whether there is huge differentiation between how professionals work and how actually, for example, students work. Of course, taking into, if we would say that learning process of CAD tool, it's done. So if we have that as a, let's say, some precondition, and then we conduct the study there, for example, although this is mostly related to design work, not to CAD, but there are some studies which actually show that students show similar patterns in their design behavior as professionals. So that's the reason why also design researchers often conduct a lot of studies on students and actually try to claim that there are clear links with professionals. Although I think we should be quite careful with generalizations like that. And there is one more thing which I think it's quite common in research, and people take into account that it's Hawthorne's effect. So people change their behavior once they are monitored. And I believe that potentially this could reflect differently on, for example, professionals and on students. This is a hypothesis. This is not something that I can claim, but potentially if they could be monitored, if they know that they are monitored, potentially they will change their behavior. So I'm not sure whether there will be the same effect on students and on professionals, but maybe others could comment.
Any thoughts on that, Allison, Ian? And if not, no problem. I think it's also interesting just to think about the other metrics and cues, that are as Stanko mentioned, that we could look at. I'm curious if there are examples or that you think of as some of the most useful insights or specific metrics that you see in the audit trail data or the Onshape analytics data that then gives us a indication that, oh, someone's in trouble. What does that look like?
So to echo off what Stanko is saying, I think if it's used in the right way, it could be very beneficial for an individual and a team, because you're getting feedback on not just the models that you're producing, but the way that you're spending your time. So Onshape will give you a perspective on whether you're part modeling, assembly modeling, what kinds of actions you're doing. And I think if that was fed back to the team and reviewed, I think it would help the team to gain insight into itself, like self-reflect. We never had those kind of abilities to look into a mirror on our own design work before. We've just focused on the CAD models alone. How time is spent on a project is been invisible to us. It has never been available to us to even look at that. But I think if that were fed back to the team, I think it could be very valuable in continually directing our energy in what's most efficient, to move the design forward.
Yeah, that makes some sense. Allison, do you want to add to that?
Yeah, so Peter, I'd say the question you just asked is sort of, again, our golden question. So a lot of our data sets that we have, we try to separate by some metric high performing teams from low performing teams. So again, another data set that we have, which Onshape and PTC were so generous, I think Ilya's right, the culture of openness to share with us, is the robots to the rescue. So First Robotics digital robotics design competition data. They even had judges who judged each robot CAD model, and so we know who did well and who did poorly. And we're undergoing a project right now to try to say, what can we see in the audit trails that might differentiate those high performing teams from the low performing teams. Something we're interested in exploring kind of relates to what Stanko mentioned earlier, which is this metric from the literature called the creation to revision ratio. So if we think about some parts of design are creating something from scratch, but then of course, all of us as designers know that a lot of design is actually iterating, changing what's been done before. And so, we're starting from really simple hypotheses, like on average, is a good team have a higher creation to revision, or maybe a lower creation to revision ratio than poor performing teams. That doesn't really seem to be a simple and strong explanation. What we're tending to see is actually that it's cyclical, which really makes sense with our intuition, right? We go through periods of design, then maybe a team design review, for example. We go through creation, revision, and sort of a convergence and divergence pattern. And so that's sort of a metric that I think might unlock a really good key performance indicators for designers, and which could be computable from the audit trail and added to the dashboard in the future, perhaps.
Cool. Yeah, it sounds like we get the impression here that, and I think it makes sense. All this research and thinking is so new, or as new as Onshape, and it seems like it's great that it sort of meets our intuition, but there's some wonderful surprises that you all come across in your research and just use of Onshape. And I'm curious, are there other interesting surprises things that you found that you didn't expect to find as you've been changing how you work with Onshape, or as you've uncovered things in your research? Any of you, whoever would like to go?
Well, one thing that Allison just mentioned is this cycle of creation and then review and revision. And that's always been part of the design process. But when I think about my previous companies that I worked for, using other CAD tools and Onshape, it seemed like we used to design in separate boxes. It used to be designers working on sections individually and then bringing the entire design together. I think of it like individuals in these locked rooms. They would go into that room and just work on their design, and what they were doing was closed off from other people. I think the way I visualize our current team is that all the doors are open and people are more free to move through the various rooms and see what's on the blueprints that they're working on and gain a much better perspective. So things aren't locked away from where others are working, and there's an encouragement to browse and understand what other people are working on. So it just feels like the doors are open with Onshape for our team, and we work differently than I ever have in the past.
Thanks, Ian. Yeah, very cool. Another great analogy and good visualization. And Stanko?
If I may add, I mean, I definitely agree. And I think it's up to us researchers actually to try to identify clear, exact metrics, which could actually help us to describe these analogies that Ian is making, and actually to showcase how this can be done for maybe different phases of the product development process. And I think this can be actually, I believe that this can be done with already what Onshape is offering in Audit Trail, because there's a lot of data, and now it's up to us to try to in discussion with practitioners to try to identify, okay, this set of data could actually help us to develop this metric. And it's up to us to develop different metrics to showcase. And it also depends on a project, whether we want to focus on creativity aspects or collaborative aspects, or for example, maybe complexity of CAD model. So there are different things that actually, depending on the type of study that we want to conduct, I think we will have to develop and tailor our CAD measurement techniques. So, but the great thing is that all these Onshape analytics actually functionalities, they offer us quite a lot, and it's up to our let's say, up to our creativity to come up with them. But I think it's not that easy process, to be honest.
That makes sense. It's establishing a new set of standards in a way, and that can be a very long process.
Makes our job interesting, though. I'll add something, Peter, that is a surprise for me, and it's actually a surprise for Ian, really hot off the press. But we've been analyzing this new big data set that he exported for us. And something that is surprising is that we found that there's not a huge amount of usage of the branch and merge feature in the data set. So I'm working with a professor in electrical and computer engineering who's really a software development expert in forks and the way GitHub allows you to essentially branch and merge. This is a really unique and cool capability in Onshape that I think, in Ian's room analogy, also lets you sort of make a mess in the house and quickly clean it up, right? What we realized in the data set from Ian's team is that really 3 people are doing a lot of the branching and merging. And so again, I said this is hot off the press, it really is. I'd really love to talk to Ian's team a little bit more to understand why those folks tend to be using that, what their experience of using branching and merging is. As I said, the software development community is a lot more mature in thinking about this, and they have best practice for when to branch and when to merge. We as CAD designers didn't train to learn this capacity. So the 3 people on Ian's team really are innovators trying out this new feature, and it seems like they like it once they use it. So, how can we help people use this feature better and create some best practice around that? My students Phil and Kathy are also working on this question.
Great, thanks, Allison. Yeah. Oh, Stanko, please.
Yeah, if I may just add, I definitely agree, and I also think that what we identified, what we realized based on our study, is that if you would analyze a range of CAD actions of different individuals, very often they're quite limited, and so they maybe use they use way less than it's available. So now we should probably try to analyze why it's like that. So whether is that enough? Is that good enough? Or maybe there are also possibilities for defining, let's say, developing learning plans So also to showcase what else they can do and how maybe they can do it in a faster way. Of course, the possibilities with tailoring features, it's even next level. But even with the basic ones, I think that this could actually help quite a lot. And I think this can be used in both domains, both educational and professional domain.
Yeah, it's great to see how Ian's perspective and his data can help you with your research efforts, and vice versa, that your findings can be translated back into practical insights to help improve, collaboration and efficiency in real product development. It's wonderful to have these collaborations. And a few of you have mentioned the idea of a mess, that students or users might create a mess in Onshape, whether they're moving things between rooms in the house analogy or just getting started. And that sort of sounds bad, but I don't get the sense that it is. And I wonder if you can talk about that a little bit. Or Allison, you're shaking your head. So why isn't it bad that the people create a mess?
Yeah, I'll send it back to Ian first. Actually, I'm curious. I agree absolutely that messes are important.
It's part of our creation process as a human. If we're doing something new, when you're being playful, like when you're finger painting or putting your blocks out on the floor, it's you have to kind of have an ability to make a jumble of things and play. I remember one of the presentations that Allison gave about Onshape and CAD, and she honed in on this word of having fun using CAD. And I always had that feeling with Onshape more than any other CAD tools I've used in the past, is it was just more fun to use. It was less intrusive, and there's a lot of thought been put into the interface. It has all the great things that have always been part of CAD, but it also moves out of the way to let you be creative and fill that page with the poem that you want to write or the painting you want to make, and you can just play with some ideas and have fun. And then that helps you to move the process forward. So I wonder if in her research, if Allison, one question I have for you guys in that playfulness is, it seems like you're developing a new branch of research that has never been available before. So how do you play with ideas and decide what you're going to research? Because you're pioneering something, both you and Stanko are pioneering a branch of research that has never existed before.
Was that a question for Alice? I think,
yeah.
Sort of.
And then Stanko, I'd love to hear too.
Sorry. I might be, maybe I'm veering off from your question, Peter.
Okay.
But you asked about making a mess and that ability, but yeah.
It is a new field, and there are a few of us working here. And when we find each other, I think like when I first met Stanko, we were like, oh my goodness, it's so great to read all your papers. I find it really fun. I find research actually to be really creative. And so I take best practices from design and apply it to my research. So one of them is find a broad set of stimuli. So I really like reading about the way computer scientists approach problems, or architects, or even what they talk about when it comes to business innovation. I also love presenting at symposiums like this because I always meet interesting people. Like I think, Ian, we first met because I presented at the Solid Professor conference, and I love meeting real practitioners who then tell me a problem that they're facing, and then I start thinking about it as a research question. And then the third thing I'll say is that I am really lucky here at the University of Toronto to recruit some excellent students, and they are uninhibited and creative and come up with really cool ideas for research directions. And so that's been a really interesting way to find new things to try out.
I mean, I agree as well. I mean, keep in mind that, very often previously, if you would analyze the different studies, people claim that CAD is not really for creative tasks, that it's also already when you have quite clear concept, quite clear idea. And I think this democratization that actually Onshape offers actually changes the game, this game quite a lot. And for that reason, I personally also, and I think our team actually finds it very, very, let's say, interesting, and but on the other hand also demanding. And I think that one way how we could come up with ideas is actually to talk and analyze CAD designers, how they behave. So try to analyze as much as possible, try to discuss with them, try to interview them, try to also, let's say, I think I would also say expose them to maybe different tasks, and also to analyze different tasks that they're going through, different types of projects. And for that reason, yeah, I think this then can offer, and I can offer really a lot, because otherwise I think it's also, we need to be aware that it's very often very hard to come up with good research questions, which are, so I think that we should search for inspiration for practitioners, but then also try to formulate it in more controlled manner. Which is quite often very hard to do with practitioners, but of course this data set now offers us quite a lot.
Thanks, Stanko, and all of you. That's great. Very interesting. I 100% agree that Onshape does a wonderful job making CAD fun and making it possible to play in that space. There was a question in the chat from Igor Werner. He wanted to know, and maybe Stanko's last note was a perfect segue, and we only have just 2 or 3 minutes left. If you could just perhaps, Allison and Stanko, tell us what are the research questions or research challenges you're interested in working on with Onshape, in specifically in education. Stanko,
you go ahead, Stanko. It's okay.
Okay, no problem. So the idea is actually to identify different patterns. I think to identify different patterns, how students use CAD, and based on that, maybe to adjust our, let's say, learning programs, or actually the way we teach CAD, the way we use CAD, the way we show students how to use CAD. That's one of the aspects. Also to maybe emphasize different aspects of maybe different CAD CAD features, for example, offered by Onshape for specific types of assignments, so that maybe we can give them some kind of proactive approach, so that we can also have some kind of reactive / proactive approach of improving our education from one year to another. Because previous, I mean, as we discussed several times, I mean, this wasn't possible, but now we have really unique data set, and I think that this can then be used for various implications for the way how we deliver our project courses, for the way how we conduct our tutorials on CAD, and I think this can then actually reflect on both, I would say, high school education, but also university education. And also, if we would have insights from professionals, and when we will have insights from professionals, maybe to let's say prepare them immediately for the way they should behave in professional environment, especially, for example, with exchanging documents, with versioning, with all these different aspects with which maybe they were not that familiar or not that interested, but they will encounter in their professional career. So to try to improve our education by analyzing patterns, by also analyzing patterns in professional behavior, and then try to use them for teaching, improvement of teaching.
Yeah, great. Allison, there's about 1 minute. Do you have a?
Sure, I'll quickly say that really I think there's 2 directions of interest. So I've already mentioned this idea of team equity when teams are collaborating with CAD. I think project-based learning is really important in education now, and Onshape totally aligns with that. So we need to make sure that we're doing things in an equitable way. The other element that I find really interesting is the way that, for example, Onshape integrates with a lot of simulation tools really seamlessly. And I think that potentially, okay, I'm going to say a third thing actually too, which is that isn't it funny that we don't teach PLM in schools, and then engineers graduate and need to know PLM as a major part of their job? Onshape, of course, is also a PLM solution. So how would we even go about teaching PLM, and how should it be integrated in our project-based learning and capstone courses? There's a ton of interesting questions.
Great. Thank you both. Ian, last word. Any thoughts on that? Exciting stuff.
Yeah, I'd love to talk more about that. Yeah, it's something that we don't, when we think about CAD, we think about sketches and extrusions and models, but the entire process of controlling that design, it's very, very important in the engineering process. And Onshape, is designed for that. It handles it so beautifully. The versioning and revisioning process is built in, but yes, it's something that I think should be part of the education system, but I don't think it has been, because it has been impractical for high schools or even colleges to set up and manage a PDM because they are so complex. They require all of the administration functions. They just don't have the resources to implement them. So students are not exposed to this fundamental engineering practice until they arrive the first day of the engineering office. And then suddenly half of what they do of managing data is brand new to them.
Got it. Yeah, lots of work to do there, and very exciting to have this opportunity through Onshape to start to answer those questions and approach and address those topics in education. So Stanko, I'm sorry, I think we're actually over time already, 1.5 minutes, but so I'm going to turn it back to Matt and say thank you to all three of you. This was a fascinating conversation, and I really appreciate your thoughtful answers and participation.